Hey guys, let's now do some practice problems with the work energy theorem. So in this first question here, I have a 5 kilogram block that is initially at rest. So let's draw this 5 kilogram block initially at rest. V initial equals 0 on a level, meaning horizontal, smooth, meaning no friction, surface. If the block is pushed with a constant force of 20, so I'm going to draw that as a pull. I'm going to call that F equals 20 for a distance of 10. So distance of 10, I want to know what is its final speed. So over here, it has a velocity initial of 0. I want to know after pulling it for 10, what is its final velocity. Okay, you could do this using a combination of F equals ma and then one of your motion equations, one of the three motion kinematic equations, or we can use the work energy theorem, which is better because it's a single step. So remember, the work energy theorem says that the net work is the change in kinetic energy. So remember that net work has to do, or work in general has to do with F d cosine of theta, and then this has to do with kinetic energy, which is half mv squared. Obviously final initial, but the idea is that if I have a force and a distance and I'm looking for velocity, I can use this equation. Okay, so the net work is the change in kinetic energy. All right, now the only force that does work on this box is F. I do have here mg going down and I have normal going up, but remember they're perpendicular to the displacement, therefore they don't do any work. So the only work here is the work done by F, which would be kinetic final minus kinetic initial. There is no kinetic initial because there's no velocity in the beginning. Okay, the work done by F is F d cosine of theta equals k final, which is half mv final squared. V final squared is what I'm looking for, and I have all the other numbers. The force is 20, the distance is 10, the angle is 0. Remember that the angle here is between the force, which is this way, and the displacement, which is also this way. So the angle here is 0 degrees, and the mass is 5, and that's what we have here. This is going to be 200, and then when I multiply by this 2 here is going to be 400 divided by 5 equals V final squared. So V final ends up being 8.9 meters per second. That's it. Let's keep going.